All right, I want to talk to you a few minutes here about solving some equations that have rational expressions in them. And I first want to start with something we've covered in the past, and that would be an equation such as this: x minus 2 over 4 plus x plus 1 over 3 equals x plus 2 over 6. Yeah, we have solved some of these already in this class. Way back in Unit 1, we talked about this. And remember what we did to solve this. What we did was we came up with a least common denominator of all these denominators on both sides. And in this case, it would be what? We got 4, 3, 6. Least common denominator of that would be 12, wouldn't it? 12 is a multiple of all those, so that's going to be our least common denominator. Now what we did with that is we took that 12 and multiplied it by all parts. Multiplied it on both sides, so it's going to be multiplied by all parts. So we've got 12 times the x minus 2 over 4 plus the 12 times the x plus 1 over 3, and then the 12 times x plus 2 over 6. Okay? Well, in doing that, this being 12 over 1, you could think of it as a fraction, 12 over 1, we've got a 4 in the denominator, 12. Those have a common factor, so we can cancel our common factors of 4 out. That'll leave me 1 in the denominator and then 3 here in the numerator. So what I have left is, I have 3 times x minus 2. And so let's write that like that. And the denominator, of course, here is 1, so I don't have to write that denominator any longer. Okay, well, similar thing happens across the board here. That's 12 over 1 again, so that 3 cancels into the 12. Common factor of 3, so reduce it by 3. We have 4, so we have 4 times parentheses x plus 1. And then last but not least, 12 over 1 again on the right, so the 6 cancels into the 12 2 times. And that leaves me then 2 times x plus 2. And so what that did was, it eliminates the denominators that we had. No longer do we have them. It's just a regular equation now. Of course, you got a little distributing to do. 3 times x, 3 times minus 2 is minus 6. 4 times x, 4x. 4 times 1 is 4. And then over here, same thing. 2x plus 4. Solve accordingly. We got like terms. 3x and 4x is 7x. Minus 6 plus 4 is minus 2. And then get the x terms. I'm going to subtract 2x from both sides. That'll get the x terms on the left, and the constant, I'm going to move it to the right here. Add 2 both sides, we get 5x equals 6. And then finish it off, divide by 5. So x is 6/5. Okay? All right, so that was something in our past. Well, I bring that up now because we can apply that to these equations that have rational expressions, such as this: 5 over x plus 3 plus 2 over x minus 1 equals 6 over x plus 3. All right, so yes, we do have an equation, rational expressions, heavily involved here, but the thing of it is, now we have variables in our denominator there, and what we're going to do is we are going to follow the same technique here. We are going to multiply LCD by, take the LCD and multiply it by all parts there to clear out the denominators, but with the variables, of course, it is a little bit looks a little bit different as far as LCD goes. So let's talk about that. So we are going to use the LCD technique, and just need to talk about what the LCD will be here. Well, whenever you're doing rational expressions, and you have binomials or trinomials or whatever involved, you are going to need a representative of each binomial, each factor, let's call it, in your LCD. So in this case, I've got the binomial x plus 3, so I need an x plus 3. Matter of fact, I got it there and there, so that takes care of that one. Then I also have the binomial x minus 1, and so I need a representative of it in the LCD. So the LCD is going to be the factors x plus 3 times my x minus 1. Pretty simple in this case. All right. Now what do? Well, we're going to do the same thing there that we did right here. We're going to multiply my LCD by both sides, which means I'm going to multiply it by all parts. So I'm going to take that x plus 3, x minus 1 times this first expression. The x plus 3, x minus 1 times the second part. And then the x plus 3, x minus 1 times the right side there. See what happens. Okay? All right. Let's see. Let me move this over just a little bit. All right, I think so. Okay. All right, well, again, this part here, make it into a fraction, so that would be over 1. And then, so knowing about our canceling here, we do have a common factor of x plus 3, so we can cancel that out, and that's going to leave me, well, it's 5 times x minus 1, isn't it? Over here, we've got the x minus 1s canceling, so that leaves me the 2 and the x plus 3. And then nicely over here, both the x minus 1 and the x plus 3 cancel, so all that's left over here will be the 6. And so voila, yes, we have no fractions now, just a nice single equation. All right, well, I see. Let me change this up. Actually, this last one over here, let's redo this one. X plus 3, x minus 1. The last one just has x plus 3 in it. I don't know where I got that x minus 1 in the bottom. It's just an x plus 3, so actually, when we cancel, the x plus 3 is all that cancels, so I have 6 times x minus 1. There we go. Now we're in business. All right, so yeah, do the little distributing here. 5 times x, 5 times 1, minus 1. It's 5x minus 5. 2 times x, 2 times 3, so that'll be 2x plus 6. Equals, then distribute the 6, so it'll be 6x minus 6, wouldn't it? Combine like terms, we've got 7x minus 5 plus 6 is plus 1 equals 6x minus 6. Get the x terms on one side, so I'm going to subtract 6x and subtract 1. And so I wind up with x equals negative 7. Everything canceling out. All right, now, before we say that is the answer, I've got to mention one quick thing here. Because of the way our original equation looks there, here's what we have to think about. We have to think about excluded values. What do I mean by excluded values? What we have to be sure is this number that we've got is not an excluded value. Yeah, because of the variables we have in being in the denominator here, yeah, we can run into these excluded values or restricted values, whatever you want to call them, because what we know is that if we get an x value that makes the denominator 0, that is bad. I don't want that. That's what we mean by excluded value. Excluded values are values that make the denominator 0. The bottom part, any bottom part up there. So I need to make sure this -7 is not one of our excluded values. Now looking back at the denominators once again, what values would be excluded values here? Well, pretty easily we can see, hopefully, if x is -3, that's going to make that denominator 0, so I can't have -3. If x is 1, that denominator is going to be 0, so 1 would have to be excluded. And of course -3 is the last one over there on the right side. So -3 and +1 would be excluded. How about -7? -7 is not an excluded value, so yeah, we can safely say -7 is our answer there. Okay? If it was an excluded value, yeah, you just reject it, throw it out, and we'll get maybe get one of those here in a second. Okay? All right, well, let's have a look here at another problem or two. All right, let's do this one. 3 over x plus 1 equals 1 over x minus 1 minus 2 over x squared minus 1. Okay, now another point to make here, it didn't come up in the previous problem, but does come up here now. Do you see here that one of the denominators is factorable? The last denominator there, x squared minus 1, does factor. Anytime you have a denominator that factors, you're going to want to factor it, okay? So that's kind of a step before even the first step over here. Yeah, the first step you want to take is look to see if any denominator can be factored. And since we've got x squared minus 1, it's a difference of squares, factor it first. Now the other two, not so much, but yeah, I'm going to factor x squared minus 1. I said it's a difference of squares. X squared is x and x. Minus 1 is minus 1 and plus 1. Okay? All right. So now we can go to our next step here is the LCD step. What would be our LCD here? Well, like we were saying, anytime you have a binomial, you need in your LCD a representative of it in there. So we've got an x plus 1 binomial, so we need it in the LCD. We've got x minus 1 in a denominator, so we need a representative of it, and then of course this one is just the same two there, so we're good to go. Our LCD in this case are these two binomials, x plus 1 and x minus 1. What do we do now? Well, now we take that and multiply it by all parts there. So I'm going to take the x plus 1, x minus 1 times everything. Times it 3 over x plus 1, times it by 1 over x minus 1, and then times it times the 2 over x minus 1, x plus 1. Okay? All right. Now, nice things happen. Again, those being in the numerator, they're over 1, so though x plus 1s in that case cancel. So I have x minus 1 times 3, let's just say 3 times x minus 1. X minus 1s cancel next, so I have 1 times x plus 1 there. And then over here, yeah, nicely, both the denominators there cancel. And so all I have left here is 2. So I have this equation now, much easier to solve. Distribute, so you have 3x minus 1. Of course, that's just times 1, so that would be x plus 1. And then minus 2. Got like terms over here on the right. 1 minus 2 gives me minus 1. Oh, wait a minute. See a little mistake here when I distribute there. That should be a 3. It'll be 3x minus 3. This will be 3x minus 3. Okay, so now we're good. Subtract the x and add the 3 to get the terms there together. So that would be 2x here equals 2, and divide by 2. And x is 2 divided by 2 is 1. All right, well, again, need to ask on this, can that be is that an excluded value, that number I get there? Well, looking back at the denominators in the original, 1 wouldn't be excluded there. That'd give me a denominator 2. However, what about here? If x is 1, denominator is 0, yes, 1 is excluded. I got to throw that one out. Now, I'm not going to work it again and get a different answer. I'm going to get the same answer every time I work it that way. This is the only possibility there was, and so since it didn't work, yeah, that equation there is one of our no solution equations. Yeah, it just that equation is just not valid. It's a no solution. Okay, so that's what you do if you get if you do get an excluded value. All right, let's talk about this one next. Here we got 4 over x plus 5 over x minus 1 equals 14 over x squared minus x. Okay. All right. So same scenario here. I've got a factorable denominator, don't I? So I need to factor that up first. So I get 4 over x plus 5 over x minus 1 equals 14. And so I factor this guy right here. It's got a common factor of x, doesn't it? So I take x out, and so an x off of that gives me x off of that gives me minus 1. Okay? So now we can do our LCD. And what would the LCD here be? Well, obviously I've got a factor of x minus 1 in 2 places, so I need a factor of x minus 1. I also notice here I've got these x's. Now, do I need another x for those? And the answer is yes, I do. Yeah, x is just a different factor than x minus 1, so I need a representative of it also in. So if we have those single x's like that, yeah, you will need a representative in your LCD. All right, so now take that by all pieces here. X minus 1 times 4 over x, x minus 1 times 5 over x minus 1, and then x minus 1 times the 14, x minus 1. Okay? Cancel things out. X cancels there, so I have 4x minus 1 times x minus 1. X minus 1's cancel here, so I have x times 5, 5x. And then here the x and the x minus 1 cancels, so 14 is all that's left on the right. So what do I have there? Well, distribute your 4, so that'll be 4x minus 4 plus the 5x equals 14. Well, 4x and 5x is 9x, so 9x minus 4 equals 14. Add the 4. Add the 4. 9x equals 18. Divide by 9. And that looks like is going to give me x equals 2. Be sure that you check to see if that's excluded value. Is it? When we go back, no, 0 is excluded there. 1 would be excluded there. Those would make the denominators be 0, so those will be excluded. However, 2, not so much. 2 is not excluded, so it's good to go. Our solution is, in that case, 2.